Recording is rolling. Welcome to Wednesday, August 20th. So we're going to continue this Algebra 1 review packet. You guys have that up. Ready to go? Oh, yeah. All right. So I'm going to pick this up from you guys by Friday. So do Friday. Tell you guys what, there are 50 questions. Think about it's a lot of questions and trying to get these through these at a reasonable pace, but I'm going to truncate this a little bit. So do you guys remember there are 7 sections? All right, so as long as you do at least 4 questions in every one of the 7 sections, I'll give you guys full credit for that. Guys, what is 4 times 7? 28. So it'd be like at least 28 questions. Now, of course, if you want to do more, that could only help you. Right, so feel free to do more, right? I'm still eyeing your guys' first quiz to be next Thursday. So Thursday the 28th, I'm still looking at that, still piece it together question by question every day. Okay. For context, today you guys had an infrastructure test in period 2, which by the way was one of my other algebra classes. And speaking of your laptop, because you need your laptop for that also. I think I want to get you guys going on Alex at some point. So I think this Friday might be a good time. The first assignment there is called a general knowledge test. So can you guys bring your laptops this Friday? Because I think that might be a good time to get you guys going on the general knowledge test. I don't know how long it is even, but if you guys open up your laptops and you're working on it, then I can see kind of gauge what's going on in that. That's fine. All right. Reminder too. A lot of you guys have fast testing this coming Tuesday, so next week Tuesday. If you're not in 10th grade, especially check that list I posted to Google Classroom and tell you exactly where you're testing. And there is a pep rally this Friday. We do have a schedule, so they just shaved a few minutes off every class, so all the classes are evened out. And we'll have a pep rally at the end of the day and get out until 2:30. So, are there any questions about any of this stuff before we get rolling on the review packet? Okay, so you guys good, All right, shuffle all this stuff away. All right, so I've taken you guys through part 3. The last one I did with you guys was number 35. You guys remember that? Okay. So again, my plan is to just do maybe a couple from every section with you guys, and then give you guys some class time in class. You should have some time in class near the end of class today to work with each other, work by yourselves. I can walk around and help you guys out. These specific questions you have. Okay. So part 5, factoring. We're gonna do some factoring. Actually, we did some factoring already yesterday for number 35. You guys, let's start here. So I'm gonna do 37 and 38 with you guys, and then I have a bonus question for you guys. So do 37. 37. Oh, 37. Factor completely. Got x squared plus 7x plus 12. Get this in here. Okay. So, but little side thought here that might eventually help out. Because what if you made this an equation? What if you did this? Here, maybe I'll split my paper and have a separate thought here. What if I said y equals x squared plus 7x plus 12? That could be a graph, right? Okay, good.
What number? I can't see.
The number 37. 37. Okay. Okay. Guys, what shape would this be on a graph? What shape graph would this make?
A square.
A parabola. Yeah, a parabola. That's it. Parabola. Okay. Guys, anytime you see y equals and there's like an x squared term, yeah, some form of a parabola. Yeah. If that's your highest order, it's an x squared. Okay. So how can you factor this? Here, and there's a few different methods to factor. One is well, you guys know it's going to take this form, right? X plus something, sort of, like that. Right? Yeah. So, what could that be? Guys, what are 2 numbers that add to 7 and multiply to 12?
3.
Yeah, 3 and 4. Yeah, 3 and 4, 4 and 3. Okay. Could you do x plus 3 times x plus 4? Or what if you reversed it? Could you do x plus 4 times x plus 3? Would that be the exact same thing? Yeah, same thing, right? Okay. Oh, no, that's factoring, right? I'm going to write the word factoring. Okay. Guys, what's the opposite process of factoring? Starts with an, FOIL, F-O-I-L. Okay. Now what I'm going to do is I'm going to check my answer using FOIL. So this is first, outside, inside, last. You guys remember that? Did we do some foiling yesterday? Thanks.
Yeah.
Okay. So first, x times x. That's x squared. Outside, 4x. Inside is 3 times x, so 3x. And last is 3 times 4. That's like 12, right? And if you combine these two middle terms, which you can do because they're both x terms, then that bring you back to x squared plus 7x plus 12. That's the same thing, right? Right.
First, I'm getting it.
Okay, you guys get that? Right. Okay, so what I'm trying to show you guys, since that matches that, is that yeah, you guys did factor that correctly. So this right here is the answer. Right, that's the answer. Right, you guys good? Is it? All this foil stuff is just to check. Yeah. Where'd what go?
7.
The 7x?
Yes, 7X.
Right here?
But that's not the answer. The answer I thought.
Oh, okay, so the answer is what I boxed in, right?
It's not the
Okay.
S4.
So you're looking for two numbers that multiply to 12, which is 4 and 3. Okay, but also add to 7. Okay.
I see.
Okay. So that, right, if you were to foil it and work backwards towards the beginning. Okay. 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 Now let's go to my graph example. Because couldn't this always be the same thing? Y equals, and could it just be this? X plus 3 times x plus 4. Okay. Oh. Now where would guys, where would this graph cross the x-axis? This is just a different way of thinking about it. Where would this cross the x-axis?
3 and 4.
Oh,
Close. Not quite.
7.
0.
Oh.
Okay. Guys, where it crosses the x-axis, isn't that where y is equal to what?
0.
0. Y is 0.
Mm.
Hey guys, for this y to be 0 right here, what would x have to be?
0.
No.
1.
2, 3, 4, 5, 6, 7.
Guys, hold on, slow down. You're going the wrong way.
Oh, is it?
Negative.
Oh, is it
Negative
negative?
3! Negative 3! That's it. Right. You're taking it. You're taking it. Or there's one more. What could 0 this bit out?
Negative 4.
Negative 4. Oh,
Red.
guys see? Here, let me hold this a little closer to the camera. Guess see if x is negative 3, that zeroes this out, therefore the whole thing is 0. If x is negative 4, it zeroes this bit out, therefore the whole thing is 0. You see that? What that means on this graph, we go 1, 2, 3, 4 left. So negative 1, negative 2, negative 3, negative 4.
Brilliant.
This graph's going to cross there and there. These 2 points right here and here. Okay. How about, guys, what's the y-intercept of this graph?
0.
7.
Well, that's equal to 0. Okay, guys, slow down. Let's think about this systematically.
Okay.
Wherever the y-intercept is, isn't it true the x value would be equal to 0?
Yeah.
So let's plug that in and see what happens. What if I plug in 0 for both those x's? What do you get?
3.
3, 4.
4.
3 times 4?
12.
Oh, that's 12. So if I go up here to 12, I'll just mark this as 12. Wouldn't this be the y-intercept right here up to 12? Right? Can you guys see the rest of the parabola? You guys see that?
Yeah, I see the parabola. I see it.
Even thought about
I see it.
So tempted.
I see it.
Isn't it? Okay. That's pretty parabola. Okay, about like that? Isn't that the parabola right there?
Oh, yeah.
Okay. All right, just think about it a little different. All right. You guys ready for a real tricky question?
Oh, no.
Because guys, this one's straight out of the packet. These are like nice numbers. Are you ready for nice numbers?
In the 6, 7? Is it 6, 7?
What if I do this? X squared plus 7x. Okay, so it's looking the same so far.
Just did that.
Plus
Nice numbers.
pi. Can you factor that? Guys, can you factor that?
Yeah.
Yeah.
No.
No.
Okay.
Pi is
Well, yes, no.
Yes.
Okay,
No.
pi is some irrational number, isn't it? So it's something weird. Okay.
4.
Can you think of are there two numbers that add to 7 and multiply to pi?
No.
3 and
Yes. No.
Huh.
Yes.
Huh.
No.
Huh.
Yes. No.
Okay. Because
Yes.
guys, what we just did a minute ago is you were factoring this. This looks pretty straightforward, right? And you said, oh, two numbers that add to 7 and multiply to 12. Well, that would be 3 and 4, and you can just factor it kind of easy, right? And then we did a FOIL check, and it all checked out. Right? Create this parabola on the graph. Okay? Okay. But what if I have something wacky like that? Right? Now, in principle, maybe you could sit here all day and figure out what numbers add to 7 and multiply to pi. Right? But there's a more systematic way. There's a different way other than just like guessing and checking. You guys want to see? Actually, speaking of parabolas, that's kind of a hint, guys. Did you guys see that this led to finding the zeros of this parabola, like where it crossed this axis? At negative 3 and
I see it.
negative 4. Okay, that's a hint to what I'm about to throw at you guys. Right, guys, there's a method. There's a process. It starts with a cube. It's called the Did you guys just say the quadratic formula?
Yeah.
Yup.
Yeah,
That's right.
That is
That's right.
exactly what we say.
That's right. You guys are on. It's the very first day of school. You guys remember the very first day of school? I gave you guys this page. Okay. One of these is the quadratic formula. Okay. You guys see that? Okay. Now I'll show you guys. Here, guys, focus here. Focus here. I'll show you guys how you can take advantage of this to also factor something wacky like this. So the idea is here, get another paper. Okay. It's that if you have something in the form. Yeah. Okay, guys. This is not in the packet. Guys, this is not in the packet. This is bonus. Everybody's taking notes right now, right? You guys got your notebooks out?
Yep.
Right. Guys, this is bonus. This is bonus. I'm showing you guys extra. Okay. If you have something in the form of ax squared plus bx plus c, okay, and I might say y equals to make an equation, but I'll just do a little different. I'll say equals 0. Right? If it's specifically equal to 0, that's kind of like saying where are the x-intercepts of a parabola, right? It's got kind of the same idea. If that's the case, then this has already been pre-solved, and that's what the quadratic formula is. Okay? You can say that every time x is going to be equal to this big old fraction. I bet there's probably a couple of guys that have this memorized already. You can tell me. How does this go? Negative.
Okay.
Negative
B
b plus or minus the square root of b squared.
B squared.
Okay.
Minus 4ac.
Right down.
Right there.
All divided by
I'm gonna wait for you.
2a. Yeah, that's it. That's it. Yeah, you guys know that. You guys know that?
Yeah.
So, all right, what we're gonna do then? All right, guys, play out this. Play out this. I'm gonna sort of make believe for a moment that this is equal to 0. Is that okay? Okay, I'm gonna put in parentheses over here equals 0, or I'll say like if it's equal to 0. Right. Then I can take advantage of this to figure out where the zeros are. Therefore, I will be able to factor it. Okay. You guys got the plan here? Okay.
Oh yeah.
So I can say that in this case, the zeros would be, so I'll say zeros are at, okay, x equals, okay, all right, so it's going to be a fraction, just like here. You guys know I'm using this as a model for this scenario. What's my negative b? What's that? Negative 7. Aha. I do plus or minus, which tells me I'm going to get 2 places, right? 2 factor. A big old square root. Stand my fraction here. What goes right here? Yeah, 7 squared minus 4 times. Ooh, what is a?
X squared.
1. It is. Isn't there implied 1 right here? Okay. Times, what's my c? Pi. Aha. Pi. And then group all this out of the radical, group the whole numerator together, and then 2a. Isn't it 2 times 1? Yeah. Yep. Is that okay? Is that what that would be? Okay. Now I definitely need a calculator for this. You guys got your calculators?
Yeah.
You guys do this along with are you guys good with that so far?
Yeah. These pretty much use the quadratic formula.
It's a different way to also do it.
So
yeah.
why do we use a graph?
Huh?
Why do we use the graph?
Because that's the third way to think about it. Okay, guys. Okay, let me pause right here. I'm gonna do a little recap. If you're ever trying to factor, if the textbook gives you nice numbers, guys.
I don't know what he's doing. Me?
Guys, look right here. Guys, if you ever have to factor something, if you have nice numbers, you could do a guess and check game. Okay, what numbers multiply to 12 and add to 7? Right. But sometimes that doesn't work out. Sometimes you get something really tricky like this, and you need a different procedure, a different method to get to the answer. And I'm using a quadratic formula to be able to also factor it, which we haven't gone to yet, but we're getting there step by step. Another way to think about it is this visualization with a graph. I'll also create a graph for this at the end, but we can't create the graph until we know what the zeros are, which we haven't solved yet. Okay, but I'll show you guys what the graph also looks like later on. Okay, so guys, follow along with me. Everybody pick up the calculator. Make sure you can type this correctly into the calculator. You get what I'm getting. X equals. Now the fact that there's a plus or minus.
Where's the x?
Shouldn't I get two answers because of the plus or minus?
Yes, we should.
So here we go. Guys, very first thing, open up a parenthesis. Does everybody have an open parenthesis?
Yeah.
Okay? Because I need to group this numerator together before I hit divide. It's easy to make a mistake.
Yes, sir.
So hit -7. Okay. Now pause right here, because on this model calculator, there are 2 minus keys. The one on the right is a subtraction. Don't hit that one right now. Guess the one at the very bottom, right? That one makes a number negative. This calculator is particular, so you have to choose that one. So at -7, plus or minus, I'll just hit plus for now. I'll do plus for now. Then hit square root. You guys know how to get a square root? Hit second root. Hit second root.
We're square. We're square.
So hit second, and key next to the 7 says x squared. So hit second, and then that key, it'll bring up a square root.
Yeah.
Okay, everybody's got a square root? Now, this little calculator automatically opens a parenthesis. Not all do. So make sure that it opens a parenthesis. No, you want the parenthesis. You want the parenthesis. Okay, do 7 squared
7 squared.
minus 4 times 1 times 5.
Wait, I gotta find the square. I gotta find
Can
the
we go
square.
back a couple steps? I'm going to the square root at. No.
Okay.
That's the-
Square root. Found it.
Okay,
Never
got
mind.
it. All right.
What happened after the first?
Don't call me that. Square root.
Square.
Hold on. Square root.
Hold on. Okay, the square key is right next to the 7.
Wait, 7? 7?
So minus 4 times 1 times pi.
Wait, that's 72?
No, 7 squared,
7.
which is like 49.
Dude, you're an idiot.
Okay.
I'm sorry.
Okay. Does everybody have up to the pi right now?
Yep.
Right.
Where do we
Now-
know the asterisks at?
Wait, I have a question.
Those are multiplies. Yeah, those little stars are multiplies.
Wait, how do you do?
Huh?
How do you do that?
Where's the passing?
Okay. You guys see right here? There's a pi key right here. There's a pi key.
Oh yeah.
It's if you don't have a pi key, can you memorize some digits like 3, 4, 1, 4, 1, 5, 9?
Don't even pay. I can't.
Yeah. Okay. So guys, I just have the pi. You guys have the pi?
Yeah.
Now close one parenthesis, and that will close the square root. Now the calculator is done taking a square root. You have to introduce another closed parenthesis. Closed parenthesis.
Holy
That closes out the numerator. You guys got that?
Yeah.
Close out the numerator.
Yeah.
Okay. Then divide by.
Bye
Hold on.
Okay, so I'm just typing this into the calculator.
Actually,
bye.
And then 2 times 1, can I just call it 2? It's okay.
Yeah.
So I'm getting. Are you guys getting negative 0.48?
I got a syntax error.
Um,
I get that.
guys, if you're getting what I'm getting, awesome. If you're not getting what I'm getting, then go back and try it again. There's a good chance, guys. It's one of two things. If you're getting syntax error, you probably hit the subtract instead of the negative, right? Another problem you might run into is if you mistype this and you end up with the square root of a negative number somehow. All right, that the calculator won't tell you. Okay.
I got 67.
Now, guys, remember this plus or minus right here? I need to go get another solution. Do I need to retype this entire thing?
No.
You're right, I don't. Because you guys see these arrow keys right here?
You're right. Go
Okay,
ahead.
scroll up. Scroll over. We're gonna change one thing. You guys see where this plus used to be? We're gonna make that a minus. So subtract. Point, subtract. Is it?
I give up.
Okay. All you need is scroll keys.
I'm tapped out.
Scroll up and replace them. Put the minus. Okay. Well, okay. And I'm getting. Are you guys also getting this? Negative 6.518.
I'm back, coach.
Yeah, you guys are back. Oh yeah.
On that
Oh
board.
yeah. You guys working? All right. You guys know I'm recording this right now, guys. I will post this to Google Classroom.
Please.
So if you're not getting these numbers, then after school today, put this in your planner. Go home and see if you can get these numbers in the calculator. All right. So what this means then is this tells me where the zeros would be on a graph if this was y equals this whole thing. So here I'll put this over here. Make a little problem. What if this was an equation? Y equals x squared plus 7x plus pi. Okay. You guys see all I did was I just made this y equals that. You guys see that?
Yeah.
Now, who knows what would that look like as a graph?
I don't know. A parabola. A parabola.
Yeah. Yeah, that would be, right? So that would be negative 0.48, which is probably right about there. X, Y. And also negative 6.5, which is, well, I don't know if it's exactly a scale, but maybe like here. 6.5. Okay. When there be a parabola that looks something like this about?
Yeah.
Right?
Yeah.
Oh.
You guys see that? Okay.
And this
And down.
sounds like graph, so like another option that we could do, or we actually
Yeah.
have to do that.
It's another way to think about it. Yeah, it's another way to think about it. Okay.
But with factoring, we have to do the.
Factoring. Yeah, let's get back to factoring then.
Wait, that was factoring.
We're about to do the factoring right now. We're about to do it right here. About to do it right here. Okay, guys, everybody back here. Everybody back here. Guys, the purpose of the quadratic formula is because I cannot easily come up with two numbers that add to 7 and multiply to pi. Right? I could sit here all day and it'd probably take me all day to guess and check.
Well, yeah.
Right? But with this process, look, I did it all on one piece of paper. And we're about to factor it just on a single sheet. So it goes like this. You guys know factoring is going to be this form, right? X. So someone did with this, right? Right? Now, you have to subtract the actual zeros. So, guys, if you subtract a negative, is that the same thing as plus a positive?
Yeah.
Watch this. Do plus 0.482. And here do plus 6.518. That's the answer. That's the answer. Okay? And I'll prove it to you guys. I'm going to do some FOIL. FOIL. Right, so I'm going to do a check right down here. Yeah, first, outside, inside, last. About to do? Okay. Yes. So let's try this out. Guys, what is x times x? X squared? Oh, yep. Alright, now, outside, inside. Guys, let's do outside, inside. Let's do 6.518x plus 0.482x. Okay? So I did this plus this. You guys got that? And, I wonder what it's gonna be. 7x. Hey, that looks like that. Because it's the same thing. Right? Plus, wait, I got one more piece to go. Last. Guys, is last this times this? Last is this times this? Let's do 0.482 times 6.518. Okay, so I did this times this. But you know what? Before I hit enter, I bet you guys know what number is going to pop up on my screen.
No.
What did you say?
About
3.14? Right? Now keep in mind these are rounded a little bit. Right, so let's see. 3.14.
Oh, that's pi.
That is pi. That's
no
pi.
way.
It's the same thing. Look at that. Right. So what are two numbers that add to 7 multiplied to pi? It's 0.482 and 6.518. That's,
Can you recite all of pi?
I only know about 8 or 9 digits.
Yeah. I only know like 6 or 7.
All right. You guys good there?
That's good. How do you know he's not making them up? You can say random numbers.
All right. How many do you know?
3.1 6776 41 14.
All right. Let's do number 38. Guys, number 38.
38. Let's go.
38.
Awesome.
Yes, sir.
I got a 4x squared minus
We
25.
should complicated as in the last one.
It's mine. You can pay attention.
Oh, keeps.
Oh, no, this one's a lot easier.
Oh, okay.
The last one wasn't even part of the book.
So you guys know it's gonna take this board.
It's the first page. We've been gone for 2 days.
You finished the first page for you.
What? No,
Either.
you. I should have did this. You.
No calling you. I have an 8.
Okay, guys. All right, back up here. Let's do 38. Okay. So I think some of you guys probably know what the answer is already. Guys,
Yeah.
somebody tell me the answer. What should I do? Should I do 2x and 2x?
Yeah.
And then what goes here and here?
Read every single one.
That makes sense.
Plus 5 and
Minus 5.
minus 5. Guys see that? Right. Now let me check my answer. I'm gonna FOIL. Let me make sure I got that right. FOIL. First outside, inside, last. Okay. Guys, what's 2x times 2x? 4x squared. Okay. And outside, is this negative 10x?
Yes.
And inside is this positive 10x?
Yeah.
So negative 10x plus 10x. And then what's 5 times negative 5? Negative 25. Is that and that the same thing?
Yes.
Yeah, sure is.
Yes.
Oh, so easy.
So here's something you can take away from this. Whenever you have a second degree polynomial, that does not have an x term, so it has an x squared and a constant like this, right? And especially if you're subtracting, you're probably get something that has some kind of symmetry to it like this. In fact, if I draw it as a graph, it's going to have some symmetry. So here's my x-axis, y-axis, like this. Right. I wonder what this parabola would look like. Suppose I do y equals. I'm gonna do y equals this. Oh, guys, what would one of my zeros be for x?
5. Yeah, I have first period.
Guys, everybody up here. I got a question for you guys.
Yes, sir.
What could x be equal to so this whole thing becomes 0?
0.
No, because guys, if you plug in 0, guys, if you plug in 0, and this is 0, this is 0, you get 5 times -5. Isn't that -25?
You're right.
That does tell you something. That actually tells you the y-intercept is down here at -25. So that is nice to know. But what about crossing the x-axis? Let's start with that one. What could x be equal to make that bit 0? 2.5. You guys see 2 times 2.5 minus 5 would be 0?
I was literally
Right here. 2.5. That's not exactly a scale, but you guys get it. Okay.
No.
And what about this one?
Negative.
-2.5. You see that?
Right.
-2.5.
Right.
Right here. And then if I finish off the parabola, because this would be a parabola if it was y equals. Like that. Okay, you guys good? Guys good?
Yeah.
Alright, next.
37 on our test.
37? That's not too bad, right?
No, but it's not good like on our test.
Maybe.
Serious about that?
Yeah, it's gonna be reasonable.
Can we
Yeah,
stop
that'd be
breaking
reasonable, right?
Don't do that.
Yes. Number 43. 43. Completing the square. Guys, this is a different method. A different method. 43. Yes. Completing the square. Yeah. Completing the square. Okay. So you guys know already that you could solve for x by factoring. You could solve for x with the quadratic formula. I mean, especially since it's equal to 0, right? Right. But there's another method we haven't even done yet. Guys, does this ring a bell? Do you guys remember completing a square?
Yep, I remember that. I
Yeah.
remember that.
Okay, I'm hearing some yes, some no. All right, so I'll walk you guys through it. Now, there's a little bit different ways to teach it, learn it, but I'll take you guys through one way. So, guys, first step, do this. Take the 7. Can you guys add the 7 over? Is that okay? The
And
7?
the 7 and the 7.
Right,
Wait,
it is. So you have x squared
Duh.
plus 6x. Okay, and this is all equal to 7. Okay, that's the first step. Okay. No, yeah, this is a procedure. This is a method. So anytime you see completing a square, you can pretty much do this process I'm doing right here. Okay, here, guys.
Sorry, it's a funny number.
Okay. Next, I'm gonna intentionally skip a line. So I'm gonna leave some space here. I'm gonna come back and fill in later, and I don't know, maybe this will make sense later. But watch this. I want to put this in this form. I want to do x plus something and square it, so I can get this equal to 7 over here. Okay. Now, if you're thinking about FOIL, you guys remember FOIL? FOIL?
Yep. Yes.
That's the same thing as like if I square something like this isn't like this times itself, it's like the same thing.
Yeah.
Right.
Yeah.
So like x and x. Right. So that outside inside step, I want something x plus something x. So something x plus itself pretty much is gonna add up to 6x. 3. Yeah, 3. So wouldn't this have to be like plus 3 and plus 3? Isn't that true?
I thought it'd be
Where did you get
32 because 32 times. Oh.
Well, here. I'm just thinking about the inside outside. So FOIL. We'll just focus on the inside outside right now. So x times x would be x squared. That's all good. And then 3x plus 3x would bring me back to the 6x. Isn't that true?
Yep.
Yeah.
So I'm going to put a plus 3 right here. Plus 3 right there. Okay? Is that right?
Yes, sure.
But you know what? I just kind of messed everything up. And that's okay. Here's why. Because what about this last bit? What about this last? Guys, 3 times 3 is what? 9. So if I expand this out, don't I have 9 too much on my left side? I have 9 too much. Okay. Now, there's a couple ways you can compensate for this. You can either subtract it off by saying -9 right here. Okay. Or could I add 9 to the other side to balance the equation?
I was thinking.
Yeah, like that. Okay. 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 Because guys, if I expand this out, this is x squared, which looks like that, plus 3x, which looks like that. Good, good. Plus 9. Oh no. But if I add 9 to the other side, then it's balanced. So now we're back to balanced equation.
Yep.
So you just add 9.
I understand.
Yeah. Okay. Now let me go back to, remember I said I was gonna skip some space on my paper? Great. Let me show you what takes you from here to here, like as a method, so you can get this right every time. You don't even have to really think about it.
Show me the map. Does he know?
So it goes like this. This is gonna do x
$50 a month.
plus, and then whatever this number is, this like b value, which in this case is 6. Always take half of that, and then it's gonna feed in right there. And then on the other side, well, actually you have to either subtract it out here or add it to the other side. Maybe I'll subtract it out here. I'll show you guys something a little different. Take half of that value squared, but you have to subtract it out to balance it out. That's equal to 7. Okay. Now in this case, half of 6 is what again? 3. In this case, 3 squared is 9. Right. So okay, so you guys see how that still balances it. Okay, it's a little bit different way to think of it. If you opened up a math textbook, they'd probably just go ahead and like chug through in that order exactly. Okay, but we still got some steps to do. We still got some steps left. So, guys, what's 7 and 9? 16. So here's at this point what I know. I know that x plus 3 quantity squared is 16, right?
Yeah.
Okay, that okay?
Yeah.
Now, we're back to just regular algebra again. Okay. What I need to solve for x. Okay? Okay? Yeah, this method's a little bit tricky, but if you run through it a few times, then be all right. Okay. So I need to solve for x. Now, algebra is a process of undoing everything that's there until you can, at the very last step, says x equals something, right? Okay. So what's the next step that I have to undo? How do you?
Square root?
Yeah, square root. Yeah, thank you. Yeah, square root. Square root. Okay. So the square root of the left side would just leave me with plain x plus 3. Is that true?
You have to ask.
Right. And then this would be the square root of 16 over here. Is that okay? But guess what just happened? X plus 3.
Make sure you ask it.
X plus 3. Guys, what is the square root of 16? 4. 4? Or negative 4. That's right. Yeah. Because isn't negative 4 being squared also back to 16? So now we're going to have 2 solutions, which maybe you could have predicted anyway. Okay. So what am I getting on this side? 1. What am I getting on this side? Negative 7. Negative 7. Okay. And then just to give you guys one more perspective, if you went back to the original statement and made it an equation, so it said y equals x squared plus 6x minus 7, and you graph that. You graph it here. I got a space for a graph right over here.
Wait. 6.
Of x-axis, y-axis. Yeah, the answer is 1 and also negative 7.
6.
And guys, on a graph, that means 6. What shape graph is this again? Parabola. Parabola. It would cross the x-axis where and also where?
1.
Yeah, a 1 and also at negative 7. And then this is your parabola right here. Okay, that's it. That's a graph. You guys get that?
6.
Hey, guys, good. Guys, good.
Take a break now.
We're going. Keep going. Going. Ooh, 44. Let's do 44.
These numbers just keep on bigger.
That's a great stuff going forward. Find the discriminant of the quadratic equation and describe the nature of the roots. So 44. I got x squared minus 8x plus 16. Okay. Notice it's set equal to 0, which is kind of setting up for like a quadratic form, right? It's like finding the zeros of the graph or the parabola. So, you guys remember x equals, you know what? Let me change this. Ax squared plus bx plus c is equal to 0. Then x equals negative b plus minus the square root of b squared minus 4ac. I'm going back to letters and make it really generic. All divided by 2a. Hey, if this is true, then this is true. Right? Guys, which part of this, and it's not the whole thing, which part is the discriminant?
What does that mean?
Yeah.
Yeah, that's what I'm asking you guys. What does that mean? What's the discriminant? You guys understand algebra 1?
One.
This bit, guys, this bit right here. This bit right here.
That's the. I actually remember that, but I don't.
No, you don't.
Yeah, you guys did learn this. Ah.
I just don't.
She does not remember.
I do
It's right. It's.
You have
Can't get it. I
discriminant.
can't. Damn.
It's discriminant.
Yeah, discriminant. Okay. Because guys, different parts of this quadratic equation tell you different properties of this parabola if it was a graph, right? Like, guys, what are you not allowed to take a square root of? A negative number. Right? There's a big old subtract here sign, which is a big opportunity to have a negative number. Is that true? So if your b squared is kind of small and your a and c is kind of big, isn't this whole bit going to come out negative? Right?
Yeah.
And that would tell you what about the parabola, if this was a parabola.
Never passed that.
Exactly. It would never cross the x-axis. I'll make 3 different graphs here. 3 different graphs. So x, y, x, y, x, y. So yeah, guys, if this discriminant is negative, if b squared minus 4ac is less than 0, then that will tell you that you have some parabola that never crosses the x-axis, like this one's floating way up here. What if b squared minus 4ac is a positive value, like it's been all day today? Then you have how many solutions?
2.
2, because when you take a square root, you get like plus or minus. Right? You might have something like this, for example, where the parabola crosses twice, right there and right there, across the x-axis twice. Right? What if, guys, what if the discriminant, this bit right here, is equal to 0? What does that mean? Has one solution exactly. Because guys, the square root of 0, there's only one number. It is 0. Square root of 0 is 0. It's the only one that does that, right? So that would tell you that your parabola just touches the x-axis at one location. That's what that means. Okay? You guys good with that? Now, let's go back to the one they gave it to you guys. Okay, so x squared minus 8x plus 16 is 0. Okay? So the discriminant, I'll say this discriminant. So b squared, is that like negative 8 being squared minus 4 times, what's a? 1? There's an applied 1 here, isn't there? Okay. Times c is 16. Right. Well, let's see what this comes out to. Guys, what is negative 8 being squared? What is that?
64.
64. Is it positive?
Yes.
Yep. Positive 64. What is 4 times 16?
Negatives of 64.
64 again. Yep, it's being subtracted. So what does this come out to?
0.
0. That's right. That's this category right here, which means that is a graph. Which one of these graphs is it? The first, second, or the third? This one right here. It's going to touch the x-axis at one point. Okay. Yeah, thank you. In fact, I know what point it's going to cross the x-axis. Oh yeah.
It's always going to be b squared minus 4ac equal to 0. It's always going to be like that.
Well, if it happens to be 0, then that means that you have a parabola that the vertex just touches the x-axis. Right? Anytime you have a parabola that the vertex touches the x-axis, then b squared minus 4ac will be 0. Yeah. Okay. And then the other two parabolas, that would not be the case. Yeah. How about a different part of this graph? Here, I'll switch ink color. Let's go PP. Guys, what about this part right here? You guys see the negative b over 2a? That tells you something different. What does that tell you about the parabola?
Oh.
It tells you the vertex, location of the vertex. Let's try it out. What is negative 8? Is that positive 8? So divided by 2a, is that like 2 times 1 is 2? Guys, what is 8 divided by 2?
-4.
Yeah, so 4, right? Because the negatives cancel, comes out to 4. Right.
4.
Actually, you know what? This is a really good model for this. If I had this is exactly 4. If this is 4 units out, that's exactly what that graph would look like. Alright, guys, ready for the next one? Next one. Alright. Ooh, we're on to word puzzles. You guys ready for word puzzles?
I'm done. I'm done.
You know what? Let me ask you guys how you want to do this.
Okay.
So we have about
Floats.
We have about 8 minutes left. All right, guys, we can spend the rest of the class. I can walk through as many as I can with you guys, or I could give you guys the last 8 minutes so we could look at these tomorrow.
Yeah. Look at
Yeah.
Yeah, you guys want to do that second option?
Look at it tomorrow.
Okay. All right. So I'll close down this recording today, and then tomorrow I'll help you guys out with these word puzzles. All right, I will walk around, help you guys out.